Hi, this is the video on question 10 I promised you. So question 10 tells us we've got three unbranched alkenes, F, G and H, and they've all got the MR equal to 70. So if they're alkenes, we can just go through all the lower alkenes. We've got the first one is C2H4, then C3H6, and C4H8, C5H10, C6H12. So ethene, propene, butene, and there's a few butenes, similar, a few pentenes, a few hexenes. And if we go for the MRs of each of these, this is going to be 28, 2 times 12 is 24, plus 8, 28, and then we add on 14 each time, because each time we're adding on a CH2. So this will be 42, this will be 56, this will be 70, this would be 84. You see how each one adds on 14. So this C5H10 is F, G and H. So they're all isomers of each other, so they're all C5H10. Structural isomers have same molecular formula, different structure. So 1 mark, I think that came up in an earlier question as well. Stereoisomers have the same structure but a different arrangement in space. So that's where EZ comes in, or cis-trans. So 1 mark for each of those. I think it's probably 1 mark for this. I'll go through, I'll bring up the mark scheme and actually go through where the marks are actually in a bit. So suggesting structures for this. Well, one of them could just be pent-1ene. So double bond on the first carbon. Now the second one and the third one, so I'm going to call this H, because F and G are EZ isomers, and we can't have an EZ isomer on pent-1ene because off this carbon we've got 2 hydrogens, so we've got the same group on the same carbon. So I'm just going to put the double bond in the middle and then have H3C here, H there, and I'm going to put the H's on the same side here. So this, because they're on the same side, Z same side, this is Z pent 2ene, and we can draw the stereoisomer of that, or geometrical isomer, which then would swap round CH2 and the CH3. So the hydrogens are now on opposite sides, the larger functional groups are on opposite sides, and that's E enemies pent 2ene. Alkanes have EZ isomerism because the double bond restricts rotation. So if this was a single bond here, and this was a single bond here, they'd be able to rotate around and take up the same position. The atoms could be in the same position in space. Because the double bond stops them from rotating, they are locked in to this positions, and so we get 2 different structures. So that's I'll go with that being F, this one being G, and that's H pent-1ene. And on the mark scheme, you get marks for your, just scroll very quickly, so 2 marks for saying same formula, different structure, so that's 2. Same structural formula, I think it needed in there, different arrangement in space, for 4 marks in total there. C5H10, some way showing that you've done that, that's 1 mark. F and G. So 1 mark for saying F and G, 1 mark for correctly identifying EZ isomers. So 1 mark each for these structures. So that's 2, 3, 4, 5. So 6, and 1 mark for doing E and Z. So just E and Z. 7. 1 mark for H. 8. 1 mark for double bonds. 9. And then you need to go into a bit more of an explanation that I did. So double bond restricts rotation. We have different groups. On each carbon. So I did explain this before, why this couldn't have EZ isomerism, because that's got 2 hydrogens and it needs to be different groups on each carbon. And I only count 10 there. Maybe there's a mark for written communication in this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because they put a no, not a 0. So there's 2 marks here. 1 mark for this structure, 1 mark for this structure, just 1 mark for E or Z. So that's 11.